Understanding how to make a great performing app has everything to do with understanding what's going on under the hood. See, if you don't know how the hardware is working, you've got a good chance of using it poorly. Now, the main question is this: how does your activity actually get drawn to the screen? Or rather, how does all that crazy XML and markup language turn into pixels that the user can see and understand? At its core, this is done with a process known as rasterization. This is the process of taking some high-level object like a string or a button or a path or a shape and turning it into pixels in a texture or on your screen. Now, rasterization is a really time-consuming process, and as such, there's a special piece of hardware in your mobile device that's designed to make it happen a lot faster. The Graphics Processing Unit, or GPU, was introduced to mainstream computers back in the early 90s to help accelerate the rasterization process. Now, the GPU itself is designed to use a specific set of primitives, dominantly that is polygons and textures, aka images. And your CPU is responsible for feeding these primitives to your GPU before it can draw anything to the screen. This is done through a common API on Android known as OpenGL-ES, which means that anytime your UI objects like buttons or paths or checkboxes need to be drawn to the screen, they're first converted to polygons and textures on the CPU and then passed off to the GPU to rasterize. And as you would imagine, this process of converting a UI object to a set of polygons and textures is not the fastest of operations. Likewise, actually uploading that process data from the CPU to the GPU isn't that fast either. So it makes sense then that you'd want to reduce the number of times you have to convert an object, as well as the number of times you have to upload it for drawing. Thankfully, the OpenGL-ES API allows you to upload content to the GPU and then leave it there. See, when you'd like to reference drawing a button again in the future, you simply have to reference it in GPU memory and then tell OpenGL how to go about drawing it. The general rule of thumb is this: optimizing for rendering performance means getting as much data onto the GPU as fast as possible and then leave it there without modifying it for as long as possible. Because every time you update a resource on the GPU, you lose precious processing time. Now, since the release of the Honeycomb version of Android, the entire UI rendering system works with the GPU. And with every release since then, more improvements have been made to the rendering system performance. The Android system does a lot, and I mean a lot, of work to reduce, reuse, and recycle GPU resources on your behalf so that you really don't have to think about it. For example, any resources that are provided by your theme, that is bitmaps and drawables, etc., are all grouped together into a single texture and then uploaded to the GPU on your behalf, alongside commonly used meshes like 9patches, for instance. This means that anytime you need to draw one of these resources, you don't have to do any conversion. See, all the content is already stored on the GPU, making these type of views really fast to display. However, this whole rendering process gets more and more complex as your UI objects get more and more advanced. Take, for example, displaying images. This actually means uploading the image on the CPU into its memory and then passing it off to the GPU to render. Using paths is a whole separate mess, as we might need to actually create a chain of polygons in the CPU or even create a masking texture to define the path shape on the GPU. Now, drawing text is a complete double whammy, right? I mean, first we have to draw the characters on the CPU to an image, and then upload that image to the GPU, and then go back through and draw a rectangle on the screen for each character in our string. Now, the performance of those operations are mostly handled by the Android system on your app's behalf, and unless you're doing something excessive, you really shouldn't see much of a GPU problem there. However, there's one GPU performance bottleneck that challenges every single developer equally. It's called overdraw.